Okay, we're going to start up the steam turbine on the MC90. So the turbo generator is what's known in this case as the steam turbine. So my steam turbine's here. What happens with the steam turbine is we supply it with some steam, and the steam passes through the turbine spinning blades. Eventually the steam makes its way down to the condenser. So really, in order for us to operate our boiler or our steam turbine, what we require is the boiler to supply it with sort of the high energy steam, and it makes its way to the low energy condenser. And what we do is we put an obstacle in the way, which is our turbine blades, and they will spin as steam wants to go from the high to low. So what we have is our steam and water side over here, and over here what we have is our lube oil side. So if we go through looking at our instructions, so I brought them up over here, turbo generator operation. So we need to make sure we have steam available at 7 bar, either from the oil fire boiler or the exhaust boiler. So let's just take a look at our boiler plant, and over here at our steam generation plant, I can see I have my boiler, it's at 7 bar pressure, so that's pretty good. I've got my burner is on, my water level looks to be under control. I'm able to supply superheated steam to the turbine, so if I follow through the pathway here, it goes to the superheater, which is down here, connects back through, and I've got a pathway. Sometimes you got to just make sure that this valve is open. It may not be open, so if you're not finding you have pressure, it might be that valve that you need to open up. Eventually that'll make me back to 86, which is where my boiler is. Just double check on my combustion side, so burner management system is on, all of my controls are in automatic, and I'm supplying this boiler with, or this supplying the boiler with heavy fuel oil. Okay, so let's start going through the steam turbine startup instructions. So first thing on page 1, and step 1 and 2, what we want to do is start up our condenser first, so before even looking at the turbine. So here's our condenser, and what it does is steam comes in after exhausting through the turbine. I create a low pressure zone inside of the condenser, which sucks steam in. When it comes in, it gets cooled. We know that steam has a great change in volume when it changes phase, so the phase change of condensing means it goes from a high volume, low pressure steam down to a very low volume liquid. Liquid collects in the bottom of the condenser known as the hot well, and it can pump it back out, and it will go back to the feed water tank to then be put back into the boiler. So in order for this to function, what I need is cooling water. So number 1, I'm going to go to page 1 and get some cooling water. So as it's set up right now, water comes in through there, goes through a pump, comes up, and in this case, looks like my valve's open, but if it's not, you'll need to open that valve and then passes through and goes overboard. This valve's open, but we look at it, it doesn't look like it's actually functioning, so I don't have any flow through it. I'm going to go back to 85 and notice that this valve is actually closed. So I'll open it up. I've got a whole bunch of turbines and components that exhaust to the condenser, so I don't necessarily need to open up all the way, but I need to make sure that I do have some flow going through. So I just set it at 25%. So step 2, start the main condensate pump, which is down here, and as well start number 1 vacuum pump. So the vacuum pump is pulling out any gases that exist in there, creating a vacuum, and my condensate pump is draining any water that's collecting in. So right now it looks like it's pretty much full with water, and so I don't necessarily want to have much water in there. So it's going to empty it out, and it's going to create a vacuum here. A couple of alarms came up, but that's not a big deal. Okay, so on to 86. Set the TG select valve to oil fuel boiler. So if assuming that we are coming from the oil fuel boiler, which we are, if you were coming from the exhaust boiler, then you would leave this or keep the pathway here, but we want to come from the oil boiler. An alarm that came up, which I believe is okay. We're just outside of the limits for feed water temperature. We want to open up a series of valves. So what we have is a steam line drain, sealing steam outlet, turbo generator outlet to main condenser. We have lube oil filter number 1, lube oil cut cooling water shutoff valve, and the sealing steam valve. Before I move on, I just want to make sure that everything is doing some sort of purpose. So I've got drain. What that's doing is I'm starting to warm up my steam line, and any water that would have collected ahead of my emergency stop valve is able to drain out. As well, new steam is coming in and it's going to heat up my line so that by the time I open this guy up, I'm not going to have as much risk of water moving its way into the turbine. I have a sealing system, so what I'm doing is I'm supplying steam to some steam seals, and what those guys are doing is a couple things. One, preventing steam from leaving the turbine, so when I add in my pressured steam, it's not going to escape through the shaft. The other thing that it's doing is it's creating a seal that's going to prevent air from getting in. So not only do I want to make use of most of my steam, the condenser is operating at vacuum, so this guy's open to that vacuum right now. I don't want to just suck air in, so it'll replace it with steam. Those guys eventually drain out to the condenser, and I have a lube oil system here, so that's going to allow me a pathway. And I've got my freshwater cooling system. If I look at here, this guy, again, same as the condenser, doesn't seem to be functioning. So I'm going to come back to number 10 and troubleshoot what the issue is. I have a cooling water system here, which goes through a number of distribution pathways. The one that I'm missing is going to the turbo generator. This guy will come up and around, either cool or be recirculated and pass through. So I see I have some flow going back to 86. I can see that I have some cooling water flow. Step number 5 is a little bit goofy. Check the level and water content of the turbo generator. What I think it should have there is turbo generator lube oil. So my lube oil tank collects some water over time. So just anywhere that it has an interaction between steam and the lube oil has the ability for that to pick up water. Over time, some of that should settle out to the bottom of the tank. And so before I start up this system, what I want to do is make sure I've drained some. And now that I've drained some, I know that my level's a little low, and I'm going to fill up my level. Step number 6 is going to be to place lube oil pumps in auto. So I've got my level into the OK range. I want to make sure I remember to close that off so I don't overfill with oil. And I'm going to turn my lube oil pump into auto. See that I've all of a sudden got flow and pressure, which is going to supply oil to my steam turbine. Temperature's low in my lube oil tank. It's actually being warmed up by the cooling water system. It's coming in at 27 degrees. My tank is 20-ish degrees, so it's starting to warm up a little bit, and it'll warm up once we get the steam turbine running. Okay, so engage the turning gear for about 1 minute. So in goes the turning gear, and I'm taking note of my time that I'm about 28. 40 about was when I put that in. And what the turning gear is doing is, first of all, I'm turning it very slowly, so 12 RPM, right? So that thing is turning 1 revolution every 5 seconds. So it's not moving very quickly. What it's doing is a couple things. First of all, what I'm doing is I'm making sure that this thing can move. So before I slam any steam into it, what I want to make sure is that mechanically it's free to move. So I don't have any broken parts. It's not been seized or jammed. What I want to make sure is that it's free to move. The other thing that it's doing is it's allowing lube oil to pass through any bearings, as well as allowing some flow of steam through the seals. Um, Sometimes what we use the turning gear to do is during the initial warm up as well. We might have the turning gear allow some steam through, so we may have some bypass line. In this case, some of the seals likely will be bleeding into the turbine, which may help to start warm it up. If there's any moisture that's accumulated, maybe the movement of the turbine inside is going to allow any water that's collected to help drain out. So I've got my turning gear. It's been a minute, so I'm going to disengage it. On disconnection, reset the turbine trip. So I have a trip still showing that I have the turning gear in. I'm resetting my trip. And hopefully at this point, I should have no alarms remaining. So as long as I have no alarms remaining, then I should be able to start the turbine. You can see here that this guy, this valve, if I have a trip showing, will close off. If I close off, it opens up. So this valve is going to be controlled by essentially the trip is one place, and we'll see what its other function is shortly. So open the turbo generator emergency stop valve to 15%. So what I'm doing is I'm adding in essentially a minimal amount of steam, and I'm just getting this thing started. So it's going roughly 1 revolution per second now, and it's starting to speed up and get going faster. So a revolution and a half per second, 2 revolutions per second. So I'm sending in some steam, and really what I'm doing at this point is I'm starting to warm up the turbine. So you can see it's at 22 degrees, 24 degrees. What's happening is I'm starting to warm up the casing. I'm starting to warm up the internal parts of this turbine. It's really important that I try and warm this thing up slowly. So we think of the turbine, and that may be a massive piece of equipment, or it may be a small piece of equipment, but either way, what it has is a lot of metal. A lot of metal in the blades, in the shaft. Even more important, a lot of metal in the external casing. All of that needs to be warmed up at about the same rate and has to be done slowly. So I don't want to risk warping my casing. I don't want to risk cracking my casing. I don't want to risk creating damage to my turbine by overheating it or doing it quickly. The other thing that happens with the turbine is that when it has cold casing, is that hot steam against cold casing is going to create condensation. So I'm going to collect moisture inside that turbine during this startup phase. And what I don't want to have happen is any moisture or a bunch of moisture collecting when that turbine's operating in a very fast speed. So I want to make sure that I'm careful with my startup. And if you look very last statement in that instructions, which maybe should be somewhere closer to the top, it's important that the turbine is started slowly. This is to reduce thermal tension during startup. If the turbine speed is taken up too fast, high vibration will occur and the turbine will trip. So step 9, the turbo generator should start to roll slowly. Let the turbine rotate for 2 minutes at this speed. So I can see it's stabilized around 400. So I'm going to let it go for about 2 minutes at this speed. couple of points of discussion. So why I don't want water to get into the turbine. Really what the turbine is just a few blades that are spinning, and I'm adding in some steam to them. And if I think of it as instead of a turbine, let's think of it as a fan moving air around your house. Um, I have the ability with that fan to take a few pieces of sand and throw them through the blades, and occasionally they're going to hit and going to cause an impact on the blades. But if I do that only once in a while, so I throw a few pieces of sand one afternoon, it's not going to damage that turbine substantially. But if I continue to do that for continuously for a week, um, throw little pieces of sand at that, eventually that fan is going to get damaged. And so what I want to do is I want to prevent, first of all, little droplets of water going through, which is the role of having superheated steam passing through this system. So hitting the blades, I don't want to have any droplets of water. So I want to make sure that I'm at um, a, a certain amount of dryness in the steam. The other thing that I want to be thinking about is the other way that I could damage that fan is, instead of throwing little pieces of sand, is to take a rock and throw it through. And so it's only going to take a few rocks to go through to that moving fan before it's going to cause damage. And so what I want to make sure is that I haven't created any slugs of water that are going to pass through the blades. And if they do go through, I want to make sure that it's not moving very quickly. So areas of concern are, first of all, ahead of any of these valves, it may have the opportunity to collect some water. So I have a drain in place. Or else inside of the casing. So anywhere where steam hits cold metal, I'm going to have the ability to create moisture and run risk of damage. So 2 months has gone by. I'm going to continue to open up the valve very slowly over up to 40% over 15 minutes. So again, what I'm doing is I'm slowly ramping this up. I've kind of made the decision that I've warmed this casing up enough that it's not going to accumulate big slugs of moisture, but I still want to be cautious with my startup. So work out how quickly you need to ramp this up, and I'm going to fast forward through the video to the point of being up to speed. So I accelerated time and I've moved myself forward. So I'm at valve is open at 40%, as the instructions have said. 15 minutes have gone by, and I'm pretty stable at just under 6,000 RPM. If I look at my instructions though, once the machine is up to speed, the emergency stop valve should be open to 100% and the steam line drain closed. So just got to be careful here. I think there's an error in the instructions. There's actually a few misleading statements. So sometimes it talks about the boiler pressure being 8. Sometimes it talks about the boiler pressure being 7. Sometimes it talks about different performance. So with us having the boiler at 7, I believe it just doesn't have enough pressure to accelerate this turbine all the way. So emergency stop valve actually needs to be open to about 45% before it will get up to full speed. And so we can see that it's starting to accelerate. And I've essentially hit my stop point. And we know I've hit my stop point because if we look at this valve, it's now starting to close. What this is the governor valve, and what it's doing is it's adjusting the speed. So I have some set point for my speed that I'm trying to hit with the turbine. While I was below that, I was just adjusting my emergency stop valve, which was bringing me up to the point of getting up to speed. And now that I'm there, this valve is taken over. And what it does is it adjusts its position to either limit the maximum speed of the turbine or increase the speed if it drops below the set point. It's known as the governor valve. So as I increase this emergency stop valve position, in order to keep my turbine at a certain rate of speed, this valve's going to adjust. So my next step in my instruction, the emergency stop valve can be open to 100% and the steam line drain closed. So I'm going to increase this. I don't want to necessarily go right up to 100% right away because I need to give my governor valve a chance to adjust and keep the speed from rocketing up. So I'm just going to go sort of step by step here, give it a few seconds to adjust. And this would be mimicking you as the operator adjusting that valve. It takes you a bit of time to open or close the valve. So I'm up to 100%, close my steam line drain, and now all of the flow is moving through the turbine. Monitor all temperatures and pressures to ensure no alarms are active. The turbo generator can now be put on electrical supply. So what I'm confirming is that I do have cooling water system running on my lube oil. It is seemingly happy and under control with the temperatures and levels. I've got flow that comes through. It only goes to two places, either down to the turbine or else into the sealing system. Makes its way to the condenser. I'm happy with flow through the condenser. My pressure is down basically to almost a complete vacuum in the condenser. I'm not overflowing in my hot well. And I also want to take a look at my boiler. My pressure seems to be stable and looks like my level is still under control. Haven't run out of water in my feed water tank, and my combustion system is not showing any trips. So at this point, what I can do is I can connect to electrical supply. I've brought up the synchronization screens, so I have page 142 and making use of the second monitor. Sorry, it's a little tough with the screencasting, but 144. So set up your two monitors to have both screens showing. This one's talking about the turbo generator. Right now, in order to activate it into the electrical system, I'm going to turn on my excitation. And what I can see is that I'm really showing frequency. If I want to see my voltage, I could look at a reading between the different phases. I have a governor here, which essentially controls the governor valve on the turbine, allowing more steam or less steam in. And I can adjust my frequency. Over on this page is the synchronization panel. And what I want to do is I want to switch my panel to turbo generator. And there's a couple things that I'm interested in here. What I'm looking at first of all is the synchroscope, and what this is telling me is when is it safe for me to connect the generator to the grid. And so what it's telling me is essentially the where I line up my AC power waveform so that I'm in sync with what the grid is doing. And really what I want to do is I want to line up so that when I do connect, I'm in the green zone so that the essentially the frequency is in phase with the grid. Right now you can see that red dot's really moving around quickly, and why that is because my generator frequency is quite a bit away from my bus frequency. And so what I want to do is I want to adjust my governor to get myself close to the bus frequency. So decrease, decrease, decrease. You have to click it on and then click it off. So some students have issues with connecting it or using the governor. It's a little sometimes confusing the first time you've used it. What I want to do is I want to get myself close to my bus frequency, and my bus frequency in this case is running at 60 hertz, 0.00, 60.00, and where I am is 60.11. So I'm a little faster, which I want. I want to make sure that when I connect in, this guy is going to be producing some electricity. It's going to be acting as a generator. What I don't want is for my frequency to be a bit slower, meaning the grid will have to push it to accelerate. What that means is that it would act as a motor. Well, I want my generator to be producing electricity, so I want it to be going a little bit faster. I don't want it to be going too fast though, because what's going to happen is when this syncs to the grid, it's going to lock into the grid speed. So I want it to have to decelerate a little bit, but I don't want to have a sudden jolt. The bigger the generator, the closer I want to be with this, but I still want to leave a small margin for error. So in case this scope is off in terms of its calibration, I want to make sure that I'm not going to backfeed power. So I'm going to wait until my synchroscope gets into the green zone now that my frequency is a little bit above. And when I do, I'm going to come over to my turbo generator page and hit the circuit breaker connect. I'm not using the connect over here on the synchronization panel. I want it off of the turbo generator panel. So you can see I'm in the green zone now, and I'm going to hit connect. What just happened is my frequency locked into 60. My power I'm starting to produce, and I have some other components here that I'm able to see. I'm creating a bit of current. So seems like all of a sudden my generator has woken up and I'm producing some power. I can increase or decrease how much power I create now. So the role of the governor now, and I'll bring up the steam turbine page. Put it behind. You can see that my governor is going to control that valve. So if I increase my governor, two things are going to happen. One, I'm going to open up this valve, sending more steam through. And two, that turbine is going to end up producing more power for me. So if I increase, you can see that governor valve's now up to 35%, 40%. And at the same time, my turbine has produced more power. This is something that I normally would want to adjust slowly. So under some steps or ramping slowly, because what's going to happen is I'm going to need to give my boiler a little bit of time to adjust. So keep up to pressure, adjust level, and as well give my condenser and turbine a bit of a chance to adjust to changing steam conditions. So we're going to bring my power up. Say we want to reach eventually up to, say, 500 kilowatts of output. And I can confirm that I'm producing power if we go back to page 70. And where that's going is either to supplying energy to the rest of the systems on board the ship or in the plant, or else in this case, what I've set up is that we're supplying power to the grid. So we've created our power plant cycle going from boiler through turbine to condenser and returning back the or the product that we're producing is electricity.